So just a few reminders here. The corn pigments have three types of corns. There's the blue corns, green corns, and the red corns. Each of them are stimulated by different components of the spectrum, with the blue being stimulated by the 420. Then as you go up, it's the green. Then the highest is the red. So when it comes to the opsins in here, you have cyanopsin, you have idopsin, and you have porphyropsin. All right. So only one of these pigments is present in each corn. You don't have a mixture um, of colors here. So um, holistically, the opsin in corns is known as photopsins, which is different from the scotopsin that we were talking about earlier. Another component that I'd like to talk about is maybe specific phototransduction in the corns. So light will activate retinin 1, and this will activate GT2, a G protein that differs somewhat from the rhodopsin transducin. Now, GT2 in turn will activate phosphodiesterase, and this will catalyze the conversion of CGMP to GMP. So this will then result in the closure of sodium channels, decreasing intracellular sodium concentration, leading to hyperpolarization, and thus will have a decreased release of neurotransmitters in the corns. Okay, only differences, we have thresholds that are different as well. Now, please note that phototransduction as a question in any given test means you writing down uh, the chemical involvement in producing impulses. Um, a re-emphasis on dark adaptation. So what happens when a person is supposed to start seeing in dim light? So persons are able to see objects in dim light usually after exposure to light. After some time, you see that they get adapted. Or the correct way to put this is that persons are not able to see. Okay, usually when you get into a room that is dimly lit, it is very difficult for you to see. But once you stay in there for a while, you have adaptation that happens, and maximum duration of dark adaptation is about 20 minutes, and you're able to see or make out or what is going on. There's also the increase of sensitivity of rods as a result of resynthesis. So you see that when once you come from a dim light and you enter a very brightly lit place, most of the pigment molecules are bleached instantly. So the time for regeneration of the rhodopsin may cause a delay in seeing objects, and so there's actually a physical sort of pain that goes with it, and you just want to close your eyes until there's an amount of adaptation to the light that you have just walked into. So when you look at dark adaptation, the cones are the first to be desensitized. Okay, you definitely can't see uh, anything when it comes to cons and darkness. So if you look at our graph, here we're looking at threshold intensity on our y-axis, and on our x-axis we're looking at the time. All right. So if you just walk in, the cons are really sensitive, but as you spend more time in the dark, you find that the cons are the first to go, and then you remain with the roads which are more sensitive and they stay on with you. So the roads maintain most visual processes due to their low threshold, and light adaptation on the other end is getting adapted to an increase in illumination. So there's a slight discomfort, as I said, due to the rapid breakdown of pigments. So do we need to know this, Mrs. Sikazwe? Yes. Another component I'd like to talk about before I call it a day is night blindness. You will notice that there's a loss of vision when light in the environment becomes dim, and for some people this is extreme. So it's um, it's known as nyctalopia. All right. So this is caused due to deficiency in vitamin A, or this because of it being low in your diet or decreased absorption from the intestine. And also with age. So you find that these people, instead of seeing what's on the left, they see what's on the right in our picture. They simply cannot see that much in darkness.